Hello, dear students. Welcome to a new session. Today we'll be talking about the relationship between the chords of a circle with its center. As you can see in this figure, that this blue segment is representing a chord. As long as we're going up and going closer to the center, the chord is getting what? Yes, the chord is getting bigger. Good job. So, the closer the chord is from the center of the circle, the longer its length and vice versa. As long as you come closer to the center of the circle, the chord is getting longer and longer. As you all know that the diameter is the longest chord in the circle. Let's check our first theorem. The theorem says, if chords of a circle are equal in length, then they're equidistant from the center of this circle. If you look at the figure, you will see that if AB is equal to CD, these are the two chords, then MY is equal to MX. This means that they're equidistant from the center. A corollary, it says, in congruent circles, chords which are equal in length are equidistant from the centers. In two circles that are congruent to each other, the chords that are equal in length are equidistant from the centers of the two circles. If you check the two circles that we have, you will see that if circle N is congruent to circle M, and AB as a chord is equal in length to CD as a chord, then automatically MX is equal in length with NY. Let's move on to the examples. We have example 1. In the opposite figure, if AB is equal to CD, check that AB is a chord and CD is another chord. Prove that XF is equal to YE. If you check it in here, you will see that AB as a chord is equal to CD as a chord. This is given. Then MX is equal to MY because they're equidistant from the center of the circle. And let's make this as the first remark. And also, you will see that ME is a radius and MF is another radius. Radii of the same circles are equal. Radii of the same circle are equal. Then MF is equal to ME. And this is the second remark. If you subtract 1 from 2, you will see that XF is equal to YE. So this is what the question is asking you to prove. Let's move to example number 2. In the opposite figure, if AB is equal to CD, then complete the following. Look at the figure as you can see in front of you. You're asking first to find the length of ME. So, from the givens, AB is a chord that is equal to CD. Then, they're equidistant from the center of the circle. Yes, exactly. So, MO is equal to ME. Then, if MO is 6 centimeters long, then automatically ME is excellent. Good job. 6 centimeters long. The second question, find the value of X. ME, you just said that's 6 centimeters long. And ME on the figure is X plus 2. So how can we get the value of X? X plus 2 equals 6. Then automatically X equals, wow, perfect, 4. Third question, find the length of CD. As you can see, chord CD, the length is given with an algebraic expression which is 3x plus 4. But now, we got the value of x which is 4. If you substitute x by 4, 3 times 4, which is 12, plus 4 is 16. So the length of CD is 16 centimeters. Wow, you guys are perfect. The converse of the theorem says, in the same circle, or in congruent circles, chords which are equidistant from the center, or the centers, are equal in length. Now let's go and check example 3. In example 3, the question says, in the opposite figure, ME is equal to MD. D is a midpoint of AB. ME is perpendicular to AC. And the last given is that measure of angle B equals 65 degrees. The question is asking you to find the measure of angle A. If we start it, you will see that ME is equidistant from the center to the chords. As long as MD is a midpoint of AB, so this angle is also 90 degrees. Automatically, if the two chords AB and AC are equidistant from the center, then these two chords are equal in length. So AB is equal to AC. Good job. In triangle ABC, what you will see that as long as it's an isosceles triangle, so this angle C is 65 degrees. Wow, you guys are awesome. So for this triangle ABC, if two angles, each of them is 65 degrees, how can I find the measure of angle A? Yes, wow. The measure of angle A equals 180 minus the sum of 65 and 65. So the measure of angle A is equal to 50 degrees. Excellent, students. Let's move on to another example, which is example 4. In example 4, the question says, two concentric circles with center M. AB is a chord in the larger circle and intersects the smaller circle at points C and D. AE is a chord in the larger circle and intersects the smaller circle at points Z and L. If the measure of angle ABE is equal to the measure of angle AEB as given on the figure, then prove that CD is equal to ZL. Let's start it together. The first thing that we need to do, yes, good job, is to construct MX perpendicular to AB and MY segment perpendicular to AE. After that, you will see that in triangle ABE, you have given that the measure of angle ABE is equal to the measure of angle AEB. Then AB is equal to AE. In the larger circle, AB is equal to AE. Therefore, MX is equal to MY. As long as MX is equal to MY, then CD is equal to ZL. Let's move to our last example, which is example 5. In the figure opposite, AB and AC are two chords equal in length in circle M. And X is the midpoint of AB, where Y is the midpoint of AC. And also given that the measure of angle CAB is 70 degrees. How can we calculate the measure of angle DME? If you can check it here, you will see that as long as AB and AC are two chords equal in length, and X is the midpoint of AB, where Y is the midpoint of AC, then, yes, good job, then you will see that MX and MY are equidistant from the chord. Equidistant from the chord means that these two angles are 90 degrees each of them. So for this quadrilateral, AYMX, as you know that the sum of measures of the interior angles in a quadrilateral is 360 degrees, so the measure of angle DME equals 360 minus 90 plus 90 plus 70 degrees. which is, yes, good job, it's 110 degrees. Let's go to the second part, which is how to prove that xd is equal to ye. As you see that ME and MD are radii of the same circle. And as long as MX and MY are equidistant from the chords of the circle, then MX is equal to MY. If you subtract the two sentences that I just said now, you will see that YE is equal to XD. So let me repeat this quickly. ME is equal to MD as they are two radii in a circle. This is statement number 1. MX is equal to MY. This is statement number 2. If you subtract 2 from 1, you will see that XD is equal to YE. Thank you very much, dear students. Take care of yourselves and good luck.